What's up, pre-calculus students? Mr. Messner here. Let's solve some equations here. Now we're getting into the good stuff. Some of these equations are easy. Some of these equations are hard. I don't really know exactly where to start to remind you of things. So I'm just gonna start getting into the problems. Um, Maybe the most common thing we're gonna be using is the inverse ideas about numbers to powers and the log base of the numbers being inverses and undoing each other. So like if you have 2 to a power x and you want to solve for x, you would take the log base 2 of both sides. That will undo what 2 is doing to x. Log base 2 of 2 to the x is x equals log base 2 of 512. I believe 512 is a power of 2, but we're going to use our calculators for a lot of these. We do want exact numbers. I believe it says find the exact number rather than a decimal. But maybe our calculator will help us find the number, and that's kind of what's fine. So what they mean by give exact values is if you get a whole number, great. If you get a decimal, just leave it in its number to a power form or e to something form. I'm using my calculator to find log base 2 of 512. You can do math up to log base 2 of 512. You can also use the change of bases formula to get this as 9, so 2 to the 9th power. So since this is a whole number, that's an exact value, that's fine. This would be the same way if I asked you to solve for this equation. I'm going to skip 2, I'll come back to 2. I would say, okay, I got 1/5 to the x. To undo the 1/5 to the power, I would take the log base 1/5 of both sides. It's 1/5 log base 1/5. And on the right side, I'm doing the same thing. And that gives me x equals log base 1/5 to the 1/25. Now, you can try to figure out this number using your noggin. It's 1/5 to what power equals 125. You could try to rewrite 125 as a 1/5 to a power. Let me show you how you do it. 125 is 5 cubed. Okay, so I'm writing this. I still can't undo this because I need this to be a 1/5. But then all of a sudden I can change 5 into 1/5 to the negative power. If I put the 5 in the denominator, 1/5 to the negative first power is 5. That cubed gives me x equals log base 1/5 to the 1/5 to the negative third. And that's how you get -3. So your answer to x is -3. You don't have to worry about that too much when you get to the calculus world. As long as you write it as this, that's fine. Or this is fine. Or this is fine. But just to show you, get that. Can't find this exact number for x. You can't simplify this in any way to find this number. So we're going to just leave the number as the natural log of something. Like e to the x, we take the log base e. The shortcut for log base e, since it's used so much, is natural log. So I take the natural log of both sides. I get x equals the natural log of 13. So just kind of showing you what I just said. If you're using your calculator and you get a decimal, that's not an exact answer. This would be considered your exact answer. X equals the natural log of 13. This is not simplified into any fraction or anything like that. You just leave it like that. Again, I'll come back to this one in a second. Let's do 5, the other 5, and 7. And then we'll come back to 2 and to 6, and we'll do some others. So if you have a number to a power, but you got other stuff going on, here I got a 6 times, here I got a +5, here I got a 6 + 3 times. It's just like you're solving an equation for x. If I have x + 5 = 60, you'd get rid of the 5 first. You wouldn't, even if you have sine of x + 5 = 5.5. you would get rid of the 5 first instead of taking the sine inverse of both sides first. You got to isolate the function that you need to use an inverse for. So it's probably instinctually what you would do, just making sure. I get e to the x equals 55. E to the x, to undo, I take the log base e. That's natural log for short. Again, x equals the natural log of 55. That's going to be a decimal. So that's that answer is fine. Just log 55, natural log of 55. The other number 5, again, if it's like 6x plus 4 equals 11, what would you do first? Get rid of the 4 first, then get rid of the 6, and then solve for x. Well, same here. Subtract the 4. I get 6 times 2 to the t plus 5 equals 7. Now, probably the first thing you guys might have thought to do was to try to simplify this. Whenever you see parentheses and a number outside of parentheses, everybody always thinks, oh, you got to distribute. You can't. Okay? This is not 12 to the t plus 5. A quick example of this, just to show you that it's not true, is like if I said, okay, what's 2 times 3 squared? Okay, simple, right? And if you did order of operations, you'd be like, okay, 9 times 2 is 18. If you thought you could simplify this because of the parentheses and take the 2 and multiply by the 3, you would simplify this to be 6 squared. But 6 squared is not 18. So this is not true. You cannot take this 2 multiplied by this 3. So many of you might have thought to do that. Don't. You're not allowed to. The number to the power takes precedence. It is kind of like it's got its grasp on 2, so you can't manipulate the 2 at all until you got rid of the t plus 5. We're not going to get rid of the t plus 5 until we take the log of both sides. So don't do that. Instead, let's just get rid of the 6 by dividing. I get 2 to the t plus 5 equals 7/6. Now I will get rid of the 2 to the power. Okay, getting rid of the 2 to the power, log base 2 both sides. Now, I know for a fact that there's no 2 to any number. There's no number where 2 to that number is 7/6. You could kind of double check that if you wanted to using your calculator. Log base 2 of 7/6 is going to be a crazy decimal, not something that's finite. So you're just going to leave this. This would be considered exact, this form. If you needed an approximation, you plug this into your calculator. You want to solve for t? Got to get rid of the 5, subtract 5 from both sides. This is your answer. This is what you would leave. This is what we would consider the exact answer. I know it's like you want to be able to simplify it more and get like t equals a number, but in this situation, it won't equal a number. It'll equal a crazy decimal. So we just kind of leave it in this form, the exact form. Let's look at 7, and then let's go back to number 2, and then we'll go to 6. I'm going to subtract 6, then divide by 3 to isolate the natural log of x. Okay, and now I have a natural log here instead of a number to a power, so we've got to remember how to do this. So isolate this like we would in any equation. Divide by 3. I get natural log x equals -2/3. Okay, how do you undo a log? Well, like if you have log base 2 of x equals 3, you would take the inverse of a log. An inverse of a log is a number to a power, the base number to the power. So this equation, to solve this equation, I take 2 to the power. 2 to the power is the inverse of log base 2. 2 to the log base 2 of x is just x. X equals 2 cubed, that's 8. So that's how I'd solve that equation. Over here, this is log base e. Natural log is log base e, so e to the power. And again, e to this -2/3 power is going to be a decimal. So you're not going to have to, plug this into your calculator and get like an exact number. It's going to be a crazy decimal. If anything, you could rewrite it to get rid of the negative exponent, just so that you know the rules of negative exponents and you know how to use them. This or this is fine, but we probably would see this maybe on a multiple choice question rather than this. Okay, now going back to number 2 and looking at number 6, there are some situations where like it is not easy to just isolate the log by adding or subtracting or dividing. Like I can't just subtract 5. I can't just add natural log. I mean, I could. There's actually 2 ways to do this. And here it's like I have e to the x in 2 different locations. I have e to the 2x and I have e to the x. So like what to do? There, this one actually I am going to. It does make sense that if I add the natural log of x to both sides, that all of a sudden this works out. I'm going to show you a different way to do this though. Kind of where I was leading to. And I could take e to the power both sides. This is log base e. So to undo it, e to the power, e to the power. This makes sense. Now e to the natural log of 5 is just 5. E to the natural log of x is just x. This makes sense. Log 5 minus log 5 is 0. Let me show you a different way to do this. Though I'd probably recommend you do this way. It's a little bit easier. You can try to simplify, okay? And that's kind of what I'm leading to get to 6. Simplifying. How do you simplify? Well, we have some log properties that we could use, right? If you're subtracting logs, it's the same as taking what's inside the logs and dividing them. And then you can rewrite this like that. Natural log, to undo it, it's log base e, take e to the power, e to the power. Now the left side just leaves us 5 over x. On the right side, e to the 0, anything to the 0 power is 1. Then I could finish off by multiplying by x. This is another way to do this problem. This is kind of like a simplify first method. And there are some situations where we'll need to simplify first, like number 6, number 9. We'll have to simplify first using log properties. And you got to figure out which ones to do what. I'm going to come back to number 6 when we see other ones like it. So I see one like 14, 15, 16. So when we get to 14, 15, 16, we'll do number 6. Let's look at number 9. Number 9 is very similar to the way I did number 2, which is, since they have a 2 here, I can't subtract the log. If I subtract the log, any of the logs, it doesn't matter. You'd have 2 minus log of x minus 1. And then if you think, oh, okay, I'm ready to get rid of the logs, you can't do it because of this 2. You can't do like 10 squared minus x minus 1. That's not correct. X to the 2 plus 3 is not x squared plus x cubed. It's x squared times x cubed. You could use a log property kind of like that, but I'll show you an easier way to do this, which is to use your log properties to simplify this into one log. If I understand that if you're adding, the exponent rule is like multiplying the stuff inside the logs into one log. I'm ready to now get rid of this log. Log is a implied base 10. So I would take 10 to the power, 10 to the power. Gives me 5x times x minus 1 equals 10 squared is 100. Okay, I'm ready to distribute. I get 5x squared minus 5x equals 100. This is a good problem. We have x squareds and x's, and this leads us to kind of like what we're going to be doing for those 3 problems that I was telling you about. Whenever you have like an x squared and an x, you need to try to factor to solve, move everything onto one side. So you probably want to move this 100 over by subtracting. Then I'll show you what else you can do. And instead of trying to factor this, there is a common factor of 5. So you can divide everything by 5, including the right side. Make sure you divide the left side and the right side. If you divide everything by 5, you get x squared minus x minus 20 equals 0 divided by 5 is 0. Now you can factor this. Now, remember how to factor. You're looking for 2 numbers that add to get -1 and multiply to get -20. You don't have to write the cross unless you really, really want to. Those numbers are -5 and +4. You get the solutions -4 and 5. We did a couple like this in our last homework. We know that you can't have the log of any base of any negative number. This can't be a negative in here. That can't be a negative in here. You can't take the log of a negative number. log of -4. The calculator's going to be like, nah. So -4 is what we consider an extraneous solution. 5 would be the one true solution. We'd want you to get both of them. All right, a couple easier ones, 8 and 10. Log base 4 of both sides. Well, 4 to the power of both sides would get rid of those log base 4s, giving us an easy equation that we could solve, which is just the inside of the logs equaling each other. I can add an x, I get 4x, I can subtract the 2, I get 4, I get x equals 1. That turns into 5, that turns into 5. So you get log base 4 of 5 on both sides. 10, we got stuff inside the log. A lot of people might think, oh, don't I divide by 4 first? You can't. Not allowed. The 4 times the x is like captured by the natural log. Order of operations would say, like, do that function first before you would be able to work with the 4 times the x in terms of undoing things. So don't divide by 4. You're not allowed to. It's inside this log. Instead, get rid of the log base e, the natural log. You get 4 to the x equals e. Now you can divide by 4. You get x equals e over 4. Not a nice number, so just leave it like that. Let's do 11, 12, 13, then we'll come back to 6, and we'll do 11, 12, and 13, and we'll do 14, 15, and 16, which are similar to each other. So again, you can't get rid of this 5 because it's inside the log, whatever the log is. You can get rid of the 3. You get natural log of 5x equals 10 thirds. I would take e to the power of both sides to get 5x equals e to the 10 thirds. Then I'd finish off by dividing by 5. Now, you want to probably try to simplify this, but you can't. This would be the exact answer. You'd get a decimal if you plug this into your calculator. This is the same kind of way where it's like you can't get rid of the square root, this minus 8. It's kind of like if I asked you to solve this equation, what I've been talking about, like square root of 2x plus 4 equals 5. You can't subtract the 4 and you can't subtract the 2 because they are inside the square root. You got to get rid of the square root first, and then you would solve. That's kind of the same thing as what we're doing here. You can't get rid of the square root. You can't get rid of the 8 until you get rid of the log, kind of the outside function. So log is a natural log. I call it log because we use it so much in calculus. We just use log instead of saying natural log. So natural log, to get rid of that, that's a log base e. You take e to the power of both sides. You get the square root of x minus 8 equals e to the 5th. I'm ready to get rid of things here. I got to get rid of the square root. Then I'll get rid of the negative 8. So I'll square both sides. Now I'll talk about this because we're going to be using actually this fact for those questions 14, 15, 16 in the previous one. The left side is x minus 8. The right side is e to the 5th squared. Now what's e to the 5th squared? Well, what's x to the 5th squared? Is it x to the 7th or is it x to the 10th? A lot of people think it's going to be x to the 10th. They think, x to the 7th. They're like, oh, don't I like add powers? But remember, like a power to a power, this is 2x to the 5th. Yes, you do multiply those things. So e to the 5th squared, I would write as e to the 10th. I finish off by adding 8. All right, so remember your powers. Let's do 13. And remember this fact because we're going to use this for those next 4 problems. I got this 6 outside the log. I got this stuff inside the log. Get rid of the stuff outside the log first. Simplifies to log base 3 of 0.5x equals 11/6. Let's get rid of this 3. Log base 3, the inverse would be 3 to the power. 3 to the power of both sides. Gets rid of this log base 3. I get 0.5x equals 3 to the 11/6, whatever that is. And then I would divide by 0.5. Dividing by 0.5 is the same as multiplying by 2. I don't like to divide by a fraction or a decimal. I'd prefer to multiply by the reciprocal. So don't divide by 0.5, though you can. you get the answer x equals 2 times 3 to the 11th sixth. Can you multiply this 2 and this 3 to get 6 to the 11th sixth? So many of you are going to think yes, but no, you are all wrong. Whoever thought that. I just showed you an example. Like 2 times 3 squared is not the same as 6 squared. 2 times 3 squared is 18. 6 squared is 36. Doesn't work. You have to leave your answer like this. This 3 is kind of like being used by the 11th sixth. You got to get rid of the 11th sixth before you can like do anything to the 3. So you can't, so just leave it like this. All right, let's go back to 6. 6 is going to be using factoring, like we did here, and it's going to be using this fact of a power to a second power. You can multiply the powers together, like e to the 5th squared is e to the 10th. Okay, because I have e to the 2x, e to the x plus 2. These are not the same e to the powers. It's almost the same. Now, we know that if you have this 2 times the x, you could actually rewrite this as e to the x squared, right? E to the x squared is the same as e to the 2x. Power to a power, you multiply the powers. I'm going to rewrite this like this because when I do that, I realize if I like replace the e to the x with just like something random like an x, this looks like x squared minus 3x plus 2. So e to the x got replaced by x. So this turns into x squared. This turns into 3 times x. Now, when you guys see this, you realize, oh, this is just a quadratic that is factorable. Find 2 numbers that add to get this, multiply to get this. And the numbers are negative 2 and negative 1. Okay, so this would be the factored form of x squared minus 3x plus 2, x minus 2, x minus 1. But what I did, I replaced x with e to the x. So I'm going to take this x here and replace it with e to the x. I can write it underneath. Or just replace it. Actually, I'm going to write it underneath. So x minus 2, x minus 1. So in reality, what we're doing is saying, oh, that's going to be e to the x minus 2 times e to the x minus 1. Now, if you solve this equation, you'd say, oh, that's simple. X is 2 and x is 1. This is not, the answers are not 2 and 1. The answers are when e to the x minus 2 equals 0 and when e to the x minus 1 equals 0. Okay, it's like when x minus 2 and x minus 1 equals 0, you easily get 2 and 1. It's not as easy here. It's similar to what we did with trig functions and like factoring sine squared things. So 2 products set equal to 0, set each of the pieces of the products equal to 0. Now we can solve. I would add 2 to both sides here. I would add 1 to both sides. And then how do I solve for x? E to the x, take the log base e of both sides. I'm taking the natural log of both sides. Natural log is the same as log base e. Natural log of e to the x is x equals natural log 2. Natural log of e to the x is x equals log base 1. Now, actually, the log base 1 is 0. That's something you actually need to know. Log base, any number of 1 is always 0. Why is that? Because a number to the 0 power always equals 1. Okay, so 6 is like 14, 15, and 16. They're all very similar in that you are going to have to factor. Now, I'm not going to do the extra step of rewriting it as x's. I'm thinking x squared minus 5x plus 6. I'm looking for 2 numbers that add to get negative 5 and multiply to get 6. That's negative 6 and positive 1. So I'm going to write this not as x minus 6, x plus 1, but as e to the x minus 6 and as e to the x plus 1. No, that's not right. I need a positive 6. Negative 3, negative 2. So, Mr. Even teachers sometimes mess up on simple factoring. Minus 3, minus 2, positive 6, negative 5. All right, cool. Now, I need these solutions to when these pieces equal zero, because this times this equals zero. Either piece could equal zero for the entire thing to equal zero. So I solve this equation and I solve this equation. Add 3, natural log both sides. Add 2, natural log both sides. Okay, I skipped the whole, natural log part step to show you, because you guys should know that by now. All right, same here. This is e to the x squared plus 9, e to the x plus 36, looking for two numbers that add to get 9, multiply to get 36. I feel like it should be a negative 9, or this should be a negative 36. Because, let's think about it. 6 and 6, it's 12. 9 and 4 is 13. I'm going to change this problem up a little bit. Let's change this to a minus. I think this will work out if I change it to a minus. $12 and 3. Yeah, so you watch. If this is a minus, I can factor this. The two numbers that add to get 9 and multiply to get negative 36 will be positive 12 and negative 3. Yeah, okay. Sometimes you got to check. So change that to a negative. Then you'd be able to factor it. That is the intent of this problem. Problems need to be set up correctly, or else it's just can't be solved, or you'd have to use a calculator to solve. But that's not the purpose of this. So this would be e to the x plus 12 and e to the x minus 3 equals 0. 12 plus negative 3 is 9. 12 times negative 3, negative 6. Okay. Set both pieces equal to 0. Now I get e to the x equals negative 12. If I want to solve for x, I take the natural log of both sides, but I get the natural log of negative 12, which can't be done. So that's considered like an extraneous solution. Here, e to the x equals 3, natural log both sides, x equals the natural log of 3. That's fine. 2 to a power. All right, well, this is 2 to the x squared plus 2 to the x minus 12. Now, a lot of people think, okay, I need to find two numbers that add to get 2 and multiply to get negative 12. But that's not really what we did here. If this number didn't exist, this 9, you'd be looking for a 1. Well, you got to consider the number that comes before the number to the power. It's not 2 to the x. It's the fact that there's a 1 here. I have 1, 2 to the x here. So this is like x squared. And if you think about it, maybe this is a good time to go back to, if you're confused, replace 2 to the x with x. Okay, so x squared plus 2 to the x is just x minus 12. You're not looking for two numbers that add to get 2. You can see it's just 1x. So you'd say, okay, positive 4, negative 3. That's what you would do here. You'd say, I'm looking for two numbers that add to get 1 and multiply to get negative 12. That's positive 4, negative 3. So 2 to the x plus 4, 2 to the x minus 3. Equals 0. Take both of these and solve. 2 to the x equals negative 4. I'm just skipping a step by 2 to the x plus 4 equals 0. Subtract 4, 2 to the x equals negative 4. To solve for this, I'd take the log base 2 of both sides, right? Log base 2. But you get x equals log base 2 of negative 4. You can't take the log of a negative number because no number to a power equals a negative number. 2 to no number is negative 4. You might be thinking 2 to the negative second. Well, 2 to the negative second is not negative 4. 2 to the negative second is 1/4. Here, 2 to the x minus 3 equals 0. Add 3. 2 to the x equals 3. Now I can take the log base 2 of both sides, log base 2 of both sides. I get x equals log base 2 of 3. That's good. Okay? If I plugged in log base 2 of 3 in for x here, I'd get a solution. Okay, some others. These kind of go back to, got a lot of problems here. Properties, simplifying things first. You might be thinking, oh, I got to take 2 to the power both sides. But I can't because it's not just log base 2. It's 3 times log base 2. This would complicate things. We're not going to do that until the log is isolated. What you can do is use your log properties to realize, oh, a product, some number times a log, you can rewrite this as log base 2 of x to the power of that number. Here, the minus, you can do log base 2 of 27 to the negative first power. 27 to the negative first is 1 over 27. You can rewrite it like that. You can worry about that later. Now we can get rid of the log base 2. Get 2 to the log base 2 of x cubed is just x cubed. X cubed equals 27 to the negative first. How do you solve? You take the cube root. Cube root is just a 1/3 power. Okay, I like doing this just to show 1/3 times 3 is 1. That's why a cube root undoes a cube. I'd have to do it to both sides. So this becomes 27 to the negative first to the negative 1/3. Multiply those powers, that's negative 1/3. I can actually figure out what this is because you can rewrite this as 27 to the positive 1/3. You know what the cube root of 27 is? It's actually 3. 3, 9, 27. So this is 1/3. Okay. Similar thing here. You can't do 2 to the power first until this 3 is gone and until you've combined your logs. So let's do that. Let's get rid of this 3, making sure that it's inside a log. Then let's combine these 2 logs using log properties. When you're adding logs together, you can just multiply their insides together. So this is log base 2 of, I'm going to write this as 4 times x minus 1 cubed, just to put this 4 in front of the x minus 1. Now I'm ready to get rid of this log base 2 with 2 to a power. Now, 2 to the log base 2, I just have whatever's left over. And again, just like with numbers to powers, you can't multiply it in. I can't distribute this 4 in because this cube is kind of taking precedence. So don't try to distribute this 4. This cube wins. 2 to the 5th, 2, 4, 8, 16, 32. Solve. Divide by 4 now. Get rid of the 4, then we'll get rid of the cube. 32 divided by 4 is 8. Cube root both sides, that's the same as a 1/3 power. We know what the cube root of 8 is. It's 2, 2, 4, 8. So I get x minus 1 equals 2. I can add 1, x is equal to 3. It's a good problem. It gives you a nice number. Oh. I'm not exactly sure how to do this one, to be honest. I have an idea on what to do, and I'll show you what that idea is. I'm going to use properties of logarithms to kind of help me out here. I'm just going to go ahead and do the log base 2 of both sides. Now, I can't do the log base 2 of the left side and log base 3 of the right side because it's not the same thing, and that would not keep your equation balanced. You got to do the same thing to both sides of an equation. So if you're thinking, oh, this is just x equals x minus 1, obviously that's not true. Now, I do the log base 2 of 2 to the x just so I can get x. On the right side, I'm going to write log base 2 of 3 to the x minus 1. And it's like, okay, well, how do I get rid of this x? Well, you can move this x minus 1 down using a property of logarithms. So I get x minus 1 times log base 2 of 3. Now, this isn't nice, and I'm sure there's another way to do this, but this is going to work out. I'm going to distribute this log base 2 of 3, which is just a number. And I get x equals log base 2 of 3, which is some number, times x, minus log base 2 of 3. Now I need to get my x's by themselves. There's definitely an easier way to do this, and I'm not gonna worry about it. So like I'm gonna move this log base 2 of 3 times x over to this left side. Or actually, let me move this log base 2 of 3 to the left side, and I'll move this x to the right side. So I'm going to add log base 2 of 3. I'm going to subtract x. So this is log base 2 of 3 on the left side now. Subtracting the x, I get log base 2 of 3 times x minus x. Now watch this. I'm going to factor out an x. So I get x equals log base 2 of 3 minus 1. So dividing it out, right, you get this. And now I can solve for x by dividing by log base 2 of 3 minus 1 on both sides, like x times this. I probably rushed through this for you guys. This is pretty advanced, at least the way that I did it. This is the answer. Certain there might be an easier way to get it. Like if I took the natural log of both sides, and you would see a different looking answer, but would be the same. Let me see, like what if I took the natural log of both sides and mark this as x log 2 equals x minus 1 natural log 3. It ends up working itself out the same way. You'd have to distribute, subtract, factor. So I don't think it would be much easier than this, but it is a different way. This is the hardest one that we've seen so far. I'm not going to show it. But maybe I do, because we have a lot more going on. I'm going to finish this video by the time class starts. Let's see. Hold on. I'm going to call Mr. Short. Let's see if I get him. You take the log or the natural log or the log of any base. Purpose is to move this down. So, all right, we'll give him a call back in a second. All right. So I got this. Move the exponents down, move the exponents down. I didn't pick a log base of something else. I just did the natural log. You could do the regular log of something. I could distribute things. I'm going to write this as 2 times the natural log of 3 times x. This is x times the natural log of 5. It's probably better to write it as the natural log of 5x. Plus, this is the natural log of 5 times x, not the natural log of 5x. That's important to write. Plus 5 times the natural log of 5. Move the x's onto one side, move the things without onto the other. So let's just add the 2 natural log 3x to the right side. Let's subtract the 5 natural log 5. I'm showing you like the other way you could have done this previously. Instead of taking the log base 2, you would take the natural log or log base 10. Doesn't matter because of the change of base formula. Now that I got this, I can factor out an x. I get natural log of 3 minus 5 natural log of 5 equals x times natural log of 5 plus 2 natural log of 3. I'm going to divide by x. And I get this crazy thing, but this is the right answer. natural log 3 minus 5 natural log 5 over natural log 5 plus 2 natural log 3. You can rewrite this so that it's 5 to the 5th power, 3 squared, but this is fine. Same thing here. So like you can take the natural log, you can take the log, you take the log base 2, you take the log base 3. It doesn't matter because you're going to use your property. Bring down the 1 minus 3x times log 2, not log base 2, but log base 10. And here bring down the x plus 1 times log 3. Distribute log base 2 minus 3x log base 2 equals log base 3 times x plus log base 3. That's times the 1. Move the stuff with the x's onto one side, move the stuff without to the other. Again, I'm going to add this just because I like adding x's rather than subtracting. So I got log 2. I'm going to subtract the log 3 on the left side. The right side, log 3 times x. I probably should put the x in front just so you're not confused with log base 3x. And I'm going to add, like I like this, the 3x log 2. Factor out an x from the right side because there's only 1 in both of them. That would be log 3 plus 3 log 2. Divide to get your answer. I get log 2 minus log 3 over log 3 plus 3 log 2. Okay, fun stuff. Don't take e to the power until you just have one natural log. Use a log property. When you're subtracting, it's like dividing. So that you have 1. You could take e to the power in this situation. It would work itself out. But this is nicer. You'll see. Now you take e to the power gives you x equals 3 over x plus 5. Let's get everything onto one level by multiplying by x plus 5. I'm going to distribute. I got x squared plus 5x equals 3. I subtract 3. And I can't factor this. I wonder if there are solutions to this. I'm going to come back and double check. I'm going to say right now cannot factor. We could use the quadratic formula. X equals the opposite of b plus or minus square root b squared 4 times a times c. That would work out, yeah. B squared minus 4 times a times c all over 2a. And those are your two solutions. It would be something that you can find. It's 37. You can't take the square root of 37. So I'm wondering if that's what we wanted to do in this situation. All right, I can power through here. So many logs. Use log properties to simplify. Log base a of x minus 1 over x plus 6 is the left side. The right side is log base a of x minus 2 over x plus 3. Take a to the power of both sides, and the log base a's go away. I get x minus 1 over x plus 6 equals x minus 2 over x plus 3. Move everything onto one side, like move everything so that it looks the same, which means like move everything up. Let's get rid of this x plus 3 in the bottom, multiply both sides by x plus 3. But at the same time, multiply both sides by x plus 6. It's essentially cross-multiplying. I don't like to say cross-multiply because students do it when it's not an equation. I like to just multiply both sides by each other's denominators. You'll see it's just like x plus 3 times x minus 1. And then x minus 2 times x plus 6. How do I solve this? You got to distribute, and you got to do some grunt work. So like x squared, I got 3x and minus 1x, so that's going to be a positive 2x, and I got a minus 3. Here I get x squared plus 4x because it's negative 2x and positive 6x, and then minus 12. This works out because I can subtract an x squared on both sides. That's gone. I got 2x minus 3 equals 4x minus 12. Subtract 2, add 12. 12 plus negative 3 is 9 equals 2x. X equals 9 halves. That's fun. Well, here we go. Let's finish off. I can do this before my next class shows up. Log base 10, get rid of it. 10 to a power. Square root x squared minus 1 equals 10 squared. That's 100. Square that. What's 100 times 100? 1, 2, 3, 4, 10,000. X squared minus 1 equals 10,000. 4 zeros, right? Yeah. Add 1. You can't get rid of this 1 until you get rid of the square root. So add 1. I get x squared equals 10,001. Take the square root of that. What's that going to be? Not a nice number. So just leave it like this. All right. 3 more. This is a tricky one because you think, oh, you're dividing. Can't I just write it like this? Nope, you can't. I mean, I could show you with like natural log of 5 divided by the natural log of 2. Let's figure out what that number is. Natural log of 5 divided by the natural log of 2. It's this number, crazy decimal, okay? But if I think, oh, that's got to be the same as natural log of 5 over 2. And I'm going to see it's not going to be 2.321. Okay, so sorry, you can't do this. So what's a way around this is actually get everything onto one level, multiply both sides by this denominator. You get log x plus 1 equals 2 times the natural log of x minus 1. E to the power of both sides, not yet. Get rid of this 2. How do you get rid of the 2? Use the log property. Rewrite this as x minus 1 squared. Now e to the power of both sides, giving us x plus 1 equals x minus 1 squared. How do I solve this? Well, let's square things because I have x's and I have x squared. This is x squared minus 2x plus 1. How do I know that? Because I know what x minus 1 times x minus 1 is. It's not x squared plus 1. I got this negative 2x. All right, I already got the x squared on the right side. I'm going to move this stuff over. We have x squareds and x's. We're going to have to factor. So I got x squared minus 3x. I subtract the 1 and it's minus 0. So that's good. X squared minus 3x is easily factorable because I could factor out an x, giving me solutions 0 and 3. Now, since I got these two solutions, like I got to go back and check. I probably should have done this for earlier, though I think I got it. If I plugged in 0, 0 minus 1 is the natural log of negative 1. Can't do that. Extraneous solution. Oh, log base 2, log base 4. Oh. I got to rewrite this as log base 2. How do I do that? I want to write this as 2 to a power, but I can't. I can't rewrite this until this is log base 2.